engineering drawing course. Today we are going to solve one problem in sections of cylinder, right? Given problem is a cylinder of base diameter 40 mm and height 60 mm rests on its base on HP. It is cut by a plane perpendicular to VP and inclined at 35 degree to HP and meets the axis at a distance 30 mm from bottom base. Draw front view, sectional top view and true shape of the section. Right? So what are the given dimensions? And now you can ask 5 questions. Yesterday I told that the first thing is what is the object here? Here the object is cylinder. And second question, what are the dimensions of the object? Here the base diameter is given as 40 mm and the height is given as 60 mm. Right? Second question. Third question, object orientation. It rests on its base on HP. It rests on its base on HP. Then fourth condition, that is angle of inclination with HP. It is given as 35 degree to HP. Right? Then the distance, the position of this section plane. Position of section plane is 30 mm from the base. These are the 5 questions we need to answer. Then before we start the problem. Now we identified it is a type 1 problem. Because type 1 is the cutting plane is inclined to HP. Type 1 is cutting plane is inclined to HP. That means section plane is inclined to HP. So we call this is the type 1 problem in the HP. If the section plane is inclined to VP, we call this type 2 problem. Now we come for the demonstration purpose by using the principal planes. Now we place this object in first quadrant. Right? Now we are going to place this object in first quadrant. Right? Now we have this. This is the principal plane. Right? You can able to see that I have this cylinder. Right? This is your principal plane. Right? HP and VP. Now we are going to place this object in first quadrant. Then we are going to do the usual method for cutting. Then we want to remove the top portions. Then we can able to draw the corresponding projections. So this is the cylinder. So for this particular position, it is a type 1. First step, you need to draw the top view of the cylinder. Then you draw its projections, its front view in vertical plane. Third step, I am going to cut the cylinder by some section plane. You need to consider this. This is actually the plane, rectangle plane, cutting plane. I am going to cut this solid like this by keeping this angle, that is 35 degree to HB, and through this midpoint I am going to cut this solid like this, slice this. Then we are going to remove the top portions. You can cut in this direction or you can cut in this direction. We can remove this portion. Then we can draw the corresponding true shape of the sections. So for this solid, the diameter is given as cylinder, diameter 40 mm and the height is given as 60 mm. Through that center point we have the axis. Right? So this is the purpose for having this demonstration. We have this cutting plane. We are going to cut for this solid like this. We are going to cut this by keeping this cutting plane 35 degree inclined to HP and remove this top portions. After placing like this, we are going to cut and remove these top portions. At the time the cutting points are marked on the top surface. Then corresponding true shape and sectional top view is we are going to draw in this problem. Right? Now we can please see our board. Right? We can able to explain. I am going to explain how we are going to complete this problem. Right? So first step, initially you need to draw one XY reference line. Right? You need to draw one XY reference line. and I am going to mark above this XY line vertical plane, below this XY line I marked as HP. Now we want to draw the top view, that is the first step, because we placing the object on HP. So we want to draw the top view of this cylinder as circle. This is the top view of this particular cylinder. You need to draw, right? Here we want to draw the circle, right? Circle whose diameter is given as 40 millimeter. So we want to draw the circle for 40 millimeter means you can take 20 mm radius. You can take the 20 mm radius in the compass. Then you can place on this drawing sheet. Then you need to complete your top. So this is the way we need to complete your first step. That means top view of your cylinder. Now the top view is we have completed. Now I am going to divide this circle into 8 divisions, for which you need to draw one horizontal line through this center point first. Then draw one vertical line through this center point O, another vertical line. Then we need to draw another 45 degree, right? We need to draw another 45 degree here. Then we need to draw another 45 degree in this rightward directions. So this is the way we need to divide the circle into 8 components. Now I am going to give the name for this bottom base of this particular solid. I am going to give the name. So bottom only we are going to first give the name. So this is A, because the top portion is removing. So we don't give the name for the top corner points, only bottom corner points. Only I am giving the name A, B, C, right? This is the point D and E, F, G and H. So this is the way you can give the points to the bottom corners for the cylinder. Now this is the point O, center point. Now I am going to draw the axis line from this point O. Now the axis line is to be drawn like this, right? Thick line. This is the way we can draw the axis line. Now you can take the 60 mm as height. This is your 60 mm. Now I am going to draw the projections from all the corner points up to this 60 mm height, right? We need to draw. So only the outer surface only visible, we can able to draw visible lines. The interior generator lines we need to draw as the lighter one. So this is the purpose. We need to draw this another projection line from this point. We can draw by using the 2H pencil. Always the interior points we need to join by this. Only outside only we need to have this darkness. So this is the way we need to draw this cylinder, right? Now I am going to mark. We can use this 35 degree inclination and means the axis at distance 30 mm, the positions. So you need to mark the center point from the top. Then you need to draw one 35 degree inclined line. This inclined line is I call as what? Section line. This inclined line is I call as what? Section line. This is 35 degree to HP. If you extend this, you will get 35 degree. So how we draw the hatching lines? The section, this section plane line is, this is the way you can darken here. After this section plane, you need to draw one small dot, then big line, right? Now you represent through this arrow. Then we can represent, this is the S for section, P for section plane. Now the remaining portion only visible, because we are cutting and removing the top portions. The bottom portion only we need to top. The bottom portion of this particular cylinder only we need to give this darkness, right, in these sides. Interior line no need to darken, and the bottom is this this also we need to darken, right? We need to darken. So this is the way we drawn this cutting plane, and the remaining portion you need to darken. Now I am going to give the points, the cutting points, right? Because this portion is removed, right? The name for this cutting points. So in OA generator line we have this point 1 dash, and here we have the 2 points on OB and OH. I will mark first 2 dash here, and in this point 3 dash. Similarly, this is the point 4 dash. Here we get 5 dash. So we are cutting this cylinder. We got these points like this. Then we move down behind this point cylinder. That points we have the OF, OG and OH, for which we have another 3 set of points. So I will mark it as 6 dash and 7 dash behind this back side. So that's why I am marking as the within the bracket. Within the bracket I mark. Now next step, we want to project these cutting points. These points we call as cutting points. We need to draw the projection line from these cutting points to the bottom generator line or bottom base. So you need to project like that way, because it cuts the generator lines exactly in at this point 1. We need to mark it as A at the point you given name as 1. B is we can give as, this is the cutting point name. C is we can write as point number 3, right? This is the point 3. At the point D we can mark 4. At this point 5, here we have point 6. This is the point 7. This is the point. So we have 8 cutting points. I marked in white color, right? So now I am going to draw this hatching line in this top view. So that's why we can get this the sectional top view. That's why we need to have this sectional top view. Now I am going to draw the 45-degree equally spaced inclined lines. 45-degree equally spaced inclined lines like this I am going to draw now. This represents actually the other lines you can remove. Only this 45-degree line only we can able to draw as the parallel line. This is the 45-degree parallel line. It represents the section portion. When we draw view from top, these portions are seen as the section 1. So that's we completed the step number 1 and step number 3. So 1 is simple top view, 3 is section top view. We also completed step number 2, that is the front view, after removing this top portion. Then we are moving into the last step, that is the 4th step. This is very important here. So you can take here. So now I am going to project this cutting plane. So for which I need space here. So I am going to draw this parallel line from SP. That is, I am going to draw another reference line parallel to this, right? Another reference line parallel to this. This is I called as another reference line. I am going to mark it as X1 Y1, new reference line. Now draw the 90-degree projector line from all these points. From 1 dash I am going to draw this first point. Then from 2 dash and 8 dash I am going to draw another projector line. Then from 3 dash and 7 dash I draw another perpendicular lines. All lines are perpendicular to section plane as well as the X1 Y1. That is the new reference line, right? New reference line X1 Y1. So I drawn all these lines, perpendicular lines, for getting the true shape of the section. Now I am going to transfer the points. Well, we want to transfer this point XY to 1. You can make measurement by the compass, right? You can transfer this point here and we can mark it as, this is my point, first point, as 1 1. I will mark it as what? 1 1. Similarly, we can mark it as from this 2 dash and 8 dash points. So you need to mark here this is the point 8 1 and this is the point 2 1. Similarly, you can measure this point 9 and 3. So I will mark this is the point corresponding to 9 1 and this is the point corresponding to 3 1. Then you can measure the distance, this 0.6 and 0.4, and we need to mark this in this particular place. So this is the 4 1 and this point I will call as 6 1. Then we finally come into the 5 1. So you measure this distance of 5 from XY reference line, you can measure by compass. From here you need to mark, then you can get this 5 1 point. So you need to join these points by smooth curve, right? 1 1 1 2 1 and 3 1 and 4 1 5 1. You need to join. For this you can use your the French curve. For this purpose only we have how to draw this, join this arc. That's why we have this French curve. You need to draw like this way. We can get this elliptical section. So we get this true shape of the section will come as ellipse. Like this way you need to draw, right? Right? This is the elliptical section, right? It's seen as the ellipse. This is we call as the true shape of the section. After drawing this true shape of the section, right? Then you can draw another 45-degree line through this, right? For representing this. Now I am going to draw in these directions the 45-degree line, equally spaced line for representing the section portion. Section portion, we want to draw this section line as a lighter line, equally spaced and 45-degree line, right? You need to draw like this way. Now we got this particular step number 4. This is step number 4. So I will give the name. 4 is nothing but true shape of this section. This section is seen as the ellipse. After removing this, the top portion of this cylinder, we can able to see this is the true shape of section as ellipse. Then this view I call as front view. This view I call as front view, and this view I call as sectional top view. This is I call as what? Sectional top view. And also you can mark the given dimensions and the angles. These angles are you mark the given dimensions and diameter we need to mark. So now we come into the end. Quick reference, quick review. So first step, take the cylinder. Before that, first you start and draw the top view of the cylinder for the given dimensions of 40 mm diameter. Then you draw the simple projections. You get the front view. For the height of 60 mm, you need to draw this simple front view. And we divide this top view into 8 divisions. Give the name as ABCD like. Then you draw the projections. We get this rectangular front view. Then you draw this axis line, right? Now we are going to draw this section plane. We are going to cut this solid in 35-degree incline to this HP. So we draw this 35-degree line here through this 30 mm from the base. You need to mark this point. Then the cutting points is to be marked on the generator point. So 1 dash, 2 dash, up to 8 dash you need to mark. Then project these points to the top view. Then we can get these top view points. Then you need to hatch this top view. We can get the sectional top view, right? Here above this portion the solid is removed. So remaining portion only you need to give the darkness. Then we coming into the true shape of the section. What we do? You need to draw the perpendicular line to this SP and leave some distance for drawing the new reference line X1 Y1. Now you take the measurement in the top view distance from XY. For example 1, 2, 3 all measurement you can taken from XY and transfers above X1 Y1 for the perpendicular lines drawn from these cutting points. We get the new points in this order. You need to join all these points then we can get this true shape of the section. You need to draw this 45-degree line for representing your solid, right? For representing the true shape of the section. That's I have completed this particular problem. Thank you.